Oh, hello, and welcome to the exciting world of E-tape calibration, or as we like to call it, sounder calibration. Okay, well, it's not that exciting, but it is a part of good technical procedures in trying to get accurate water level measurements down a well from land surface. And in the interest of accuracy and repeatable results, what we find is a can of worms. It's not really that bad, but what we need to do is find any impairment to the tape due to, say, a knot, or a kink, or a stretching of a tape down a well due to the weight of the probe, or maybe it's stuck. To do a calibration, the sounder is measured alongside a standard. We're using a steel tape that is not used in the field, only for the calibration. It's important that the 0 point on the sounder is identified. The 0 point is actually the point on the probe where contact with the water will complete the circuit and sound the buzzer. The two 0 points, that of the sounder and of the steel tape, are aligned and firmly affixed together. Care is needed to attach the two together with enough strength to not move when a force is added to approximate a probe or cable load. To make a horizontal approximation of vertical forces, we constructed a setup with a scale to apply the load and a turnbuckle to fine-tune the adjustment on the scale.
9.
Readings from the steel calibration tape are compared to the readings on the sounder and logged.
3 feet is...
This spreadsheet is our calibration log, where for every sounder E-tape, we provide a list of our measurements that we made out in the field. Okay, this is one of the pages of the E-tape that we were calibrating outside. And some of the things we put on the log is the serial number, the type that it is, the date, the time, kind of a quick description of the weather. And what I've got over here in this column is the steel tape measurements, the standard tape, the settings that we have. And then in the sounder, those are the measurements that we actually read off opposite to this point in the steel tape. And we created a graph that will give us a slope trend for our corrections. So all you need to do then is type in whatever sound number comes out when you hit the water, and then a modeled correction shows up over here, and this is the number that we'll use to correct our reading. The best technique to calibrate a sounder needs to be accurate enough and straightforward enough to actually get used and logged, so as to meet U.S. Geological Survey data collection standards.